Hello everyone, we will discuss this problem F of AtCoder 306 merge sets. So what does the problem say? First thing it defines a merge operation. So it says that you are given two arrays A and B, and we are assuming that A intersection B is equal to 5. That means there is no element common in both of them. Like one is present here, but one will not be present here. Now the merge score of the two elements is obtained by number one, you merge them. So if you merge A and B, you get this new array of size 2n, if n are the number of elements. And then whatever is the first array, right? You are merging A comma B, right? So score of A comma B is equal to, you only look at A is the first one. So what you do is you look at all the elements in A and you find their indexes, their position in the merged array, like sorted merged array. So 1 is present at the first index and 3 is present at the third index. So in that case, the the merging score of A and B is equal to 1 plus 3 equals to 4. You are only concerned with the first, like you don't look at these elements, right? Only the first array. Now that's the merging score. Now, according to the question, you are given a set of arrays. Like this merging score was defined for two arrays. So you're given a set of arrays, you're given a set of n arrays, and each array has m elements. And no two arrays have any common elements. So uh, all the elements in if you pick this array and this array, then they will have distinct elements. What you want to do is you want to find the overall merge score by looking at all pairs of arrays. So if this is array 1, 2, 3, and 4, you want to find the score of 1, comma 2. So 1 with 2, then 1 with 3, then 1 with 4. So 1 plus comma 3 plus 1 comma 4 plus then you, so this is the first array in merging. Then the other pairs will be 2 comma 3 and 2 comma 4. So 2 comma 3, 2 comma 4, and the last pair will be so score of 3 comma 4. Okay, something like this you have to find out, and this the score formula is this. Okay, so if you just read the statement quickly, you have to find the summation of f of si sj, and si and sj are like arrays. So this is s1, this is sn, and they have also defined the merging score as something like summation of indexes of the first array in the merged vector, and this is the example that I discussed. Okay, so let's in the example test case, this is one test case given. So the merge score here will be you will merge these two. So this I've already discussed, so the answer will be 4. Then when you merge these two, the merged array will look like 1, 3, 4, and 6. And then you will look at the indexes of 1 and 3, the first array. So 1 is present at the first index, 3 is present at the second index. So you will add 1 plus 2, 3. And then the third merging will be here between these two. So the array will look like 2, 4, 6, and 8. So 2 is present at the first position, 8 is present at the fourth position, so plus 5, which is equal to 12. Okay, so this is one of the examples. Now, how do we solve the problem? Well, the way I solved it is, suppose we are given these set of arrays, right? And suppose I am looking at the, I am considering this ith array to be my first array. So like we have to find the score, right? So we will find the score of s of I, comma some s of k, and k is like one of these arrays. Okay. So now in this ith array, what I am saying is that each element contributes something to the final answer. So each element contributes something. Okay. So for example, if we look at this jth element, okay, when these two arrays are merged, then in the overall um, in the new array, the merged array, this jth element will be present somewhere. Suppose it is present somewhere here at some x index, right? X1 index. Then in the second merge operation, suppose I is merged with this. So then you will obtain another new array. So in that case, the jth element in the new array will be present at some other position, x2, and so on. So in the second time, it will be present at some xth position, x2 position, and the last merge, it will be present at some x. It would be, I think, n minus I minus 1. Because if this is the ith index, then um, these elements will be n minus I minus 1, assuming zero-based indexing. So like these many merged arrays will be made with this as the first array. Okay. So basically, I will try to find uh, summation of, basically I will try to find x1 plus x2 plus xn minus I minus 1 for this jth element, and that will be its overall contribution to the answer, because in this merge it is present at the x1 position. So the score is what? The score is the sum of the positions of the first array. So it was present at the x1 position, so the contribution will be x1, and so on. Now the question arises is, how do I find this? How do I find the overall contribution? Okay. So let's assume the same thing. Let's say that this is the jth element. When the jth element is merged, so what is its position? Its position is basically equal to the number of elements which are less than it. Okay. So suppose this jth element is merged with this array. So how many uh, elements are less than it in the new merged vector? Well, these elements will be less than it because like they're obviously less than it because it's a sorted vector, and we are assuming zero based indexing. So total j elements will be less than it, and there will be a set of elements in this as well. Suppose we call them as p1, because the question says that these arrays are in sorted order as well. Even if they are not, we can just sort them. That's fine. So there will be some set of elements p1 which are less than the jth element. So the position of the jth element will be simply how many elements are less than it plus 1. So it would be j plus p1. Um, if there is nothing less, yeah, its position will be j plus p1. We are assuming zero based indexing here. So for example, there are 3 elements less than this element here and 4 elements less than this jth element. So there will be total uh, uh, from index 0 to 6 will contain the elements less than it, and then you will be present at the jth element will be present at index 7. So its position will be basically j plus p1. Now in the next merging, and this will be the value of x1, assuming zero based indexing. For one based indexing, we just have to add one a number of times. So that we can handle at the end. Then in the next merge, again its new position will be similar to this. So its new position in the next merge will be x2, which will be equal to j plus p2. Why j? Because j elements will still be less than it, and then assume that some p2 elements are also less than j in this array, and so on. The final array will have, I think, something like p of n minus I minus 1, something like that. So p of this. So x of n minus I minus 1. In in this merge, its position will be j plus some p of n minus I minus 1. Okay. We don't know these p1, p2 and all these, but we know p1 means the number of elements less than this array of jth element. So now what will be the total contribution? The total contribution will simply be, if you add all these, it would be j plus p1 plus j plus p2 plus so on, which will be equal to j into, I think, n minus I minus 1 plus summation pi, I equals to 1 2. So this term is very easily calculated. J is the index, so um, we know that, and n minus I minus 1 is also, like, we'll be iterating over all the elements in the array, right? So this is easy to calculate. Now, how do you calculate this? This basically means that in all of these arrays, how many total elements are less than array of j? And you can very easily do it by you can maintain a segment tree over for the entire given input, and then suppose you are at the ith row, so remove all of these elements from the segment tree because they will not contribute to this p1 p2 p3 value, and then for each jth index just query in the segment tree from array of j plus 1 to sorry, it will be all the elements which are total number of elements which are less than it. So query from um, minus infinity to array of j minus 1, something like this, right? So you can just simply query in the segment tree, and then once this row is complete and you are coming to this row, then again you will update the segment tree. You will uh, remove the count of all of these elements from the segment tree, and then for each element here you want to find its contribution to the answer. So you can just do a simple query in the segment tree, and then you can also add this term to your answer. One last thing, that this here assumes that you are dealing with zero-based indexing, but since you are dealing with one-based indexing, so to your final answer, right? Um, like, or instead of adding to your final answer, you can also add per element. So suppose you are at this particular element, I comma j element. Suppose you are at element in the ith row, you are at the jth element. So this is the contribution of assuming zero-based indexing. But in all of the sorted vectors, um, for one-based indexing, you will add plus 1 as well. So I think you will add j n minus I minus 1 again. So this will be the total contribution. This accounts for one-based indexing. So I will show you the code. Um, Sorry, let me copy it here. And yeah, so you are iterating over all the rows. You are iterating over all the elements. You first remove these elements from the segment tree because you are only concerned with elements from I plus 1 from the I plus 1th row to the n minus 1th row when you're at any I, and then you are going to query in the segment tree. You want to find all the elements which are less than u. So you will add that to the answer. You are also going to add this term because there are j elements less than u in your in the current array, and how many total merges you will be there in? You will be total in n minus I minus 1 merges. And then this is here for one-based indexing. And then you'll just print it. Instead of a segment tree, you can use a Fenwick tree or anything. Uh, the Even if you look at the task and the uh, time complexity, it is 4 seconds, so it will easily pass. And make sure that like you don't use integer, like you don't use long types in this. So if you do, then you might get a wrong like time limit exceeded. Only the answer should be long. The rest should be integer type. That's all for the video. Thank you for watching. Bye bye.